For decades, humanity's greatest question was simple. Are we alone? We searched the skies with telescopes, scanned the stars with radios, and pointed our satellites at every suspicious flicker in the dark. And every time, the answer came back the same. Silence. Planets too hot, too cold, too barren. Stars too unstable. Galaxies too far away. It was comforting in a way. Earth might be fragile, but at least it was special. At least we were unique. But then James Webb opened its golden eyes and everything changed. The James Webb Space Telescope was never supposed to play it safe. It was designed to look deeper, sharper, and stranger than any machine before it. Its golden mirrors are not just lenses. They are time machines peeling back billions of years and to see the universe as it was before Earth itself existed. For the first time, we could watch the universe being born, galaxies assembling, stars igniting, worlds forming. But Webb didn't just confirm what we suspected. It began breaking the rules we thought were unbreakable. And in that brokenness, something disturbing appeared. Because what Webb has revealed is not a quiet cosmos humming predictably in the background. It is a universe that refuses to behave. Galaxies forming too early, planets breathing too strongly, signals whispering of life where there should only be rock and gas. Webb hasn't just updated astronomy, it has destabilized it. The discoveries are real, the data undeniable, but the meaning? That is where the unease lives. Each observation Webb sends back doesn't just answer a question, it asks a darker one in return. What if life is not rare? What if it is inevitable? What if we are not the exception but the rule? And perhaps most unsettling of all, what if life has always been out there, watching, waiting, existing, in forms so alien we would not even recognize them if they were right in front of us? These are no longer science fiction questions whispered in late-night conversations. They are questions forced upon us by Webb itself. The telescope humanity built to find clarity may have instead opened a door to chaos. This is the story of what Webb found when it peered too far. A story not of comfort, but of contradiction. Because the most dangerous discovery of all is not that we are alone, but that we might never have been. In the beginning, the universe was chaos. That's what every cosmology model told us. After the Big Bang, the cosmos should have been a violent ocean of raw energy, thick clouds of hydrogen and helium swirling without order, a fog so dense that even light itself was trapped. It took hundreds of millions of years for that fog to thin, for gravity to weave its invisible threads and gather matter into clumps we now call stars and galaxies. By the time Earth was born billions of years later, the story was supposed to be clear. Galaxies take time, structure takes patience, and the early universe should have looked primitive, half-finished, like sketches on a cosmic draft board. The rules were supposed to be simple, time first, complexity later. And then Webb saw Z14, a galaxy so large, so luminous, so impossibly structured that it shouldn't exist at all. According to our models, galaxies like the Milky Way needed billions of years to sculpt themselves from chaos. Yet Z14 appeared fully formed just a few 100 million years after the Big Bang, a blink in cosmic time. Imagine walking into a construction site on Monday, foundations barely laid, and returning on Tuesday to find a fully built skyscraper. Glass windows glittering, elevators running, people already moving in. That is what Z14 represents. Not gradual assembly, but an overnight leap into maturity that defies everything we thought we understood about cosmic evolution. The discovery left astronomers unsettled. Our models of dark matter, gravity, star formation, all of it strained under the weight of this single galaxy. If Z14 is real, then the early universe was not a child slowly learning to walk. It was a prodigy, sprinting before its bones had even formed. The light Webb captured from Z14 had traveled for over 13 billion years, carrying with it a message from the edge of time. And the message was clear. The rules we trusted were not the rules the universe followed. Galaxies were not waiting patiently for permission to form. They were breaking out of the fog far earlier than they had any right to. What does that mean? Some physicists suggest our understanding of dark matter is flawed, that its invisible scaffolding may have clumped faster and stronger than we expected, dragging gas into dense structures. Others whisper about exotic physics, forces beyond our equations that accelerated cosmic architecture like a hand sketching too quickly. A few even suggest the most haunting possibility of all. Maybe the early universe itself was unstable. Maybe the physics we take for granted today, the constants, the laws, the symmetry, wavered in those first moments, allowing impossible structures to emerge before stability locked everything into place. If that is true, then Z14 is not just a galaxy. It is evidence of a universe that once broke its own rules and maybe could again. And here lies the fear. If physics itself was unstable once, what stops it from unraveling in the future? If galaxies could cheat time, what else could cheat the laws we think are unbreakable? The discovery of Z14 is not just a marvel, it is a warning. It tells us that the cosmos we inhabit is less predictable, less obedient, less safe than we imagined. Because if a skyscraper can rise overnight in the middle of a construction site, then maybe the foundations of reality are not as solid as we believe. Maybe the universe is not a patient architect. Maybe it is a gambler rolling dice we do not yet understand. And Z14 is the jackpot that proves the house always wins. For decades, the search for alien worlds had been a catalogue of disappointment. We found gas giants orbiting too close to their stars, scorched into barren embers. We found frozen spheres drifting too far from warmth, their surfaces locked under miles of ice. We found rocky planets that at first glance seemed promising, only to discover they were drenched in carbon dioxide, thick enough to suffocate anything that dared to breathe. Every discovery seemed to whisper the same truth. Earth was the exception, not the rule. Earth was rare. Earth was special. And then Webb turned its golden eye toward a star, 124 light-years away, in the constellation Leo. What it saw shattered the silence. The planet was called K2-18b, and unlike all the others, this one seemed to breathe. Webb's instruments are so sensitive they can read starlight as it filters through a planet's atmosphere during a transit. Imagine looking at a candle through a glass of water, the flickering light bending and changing as it passes through the liquid. By decoding those subtle distortions, scientists can read the chemistry of worlds they cannot touch. When they pointed Webb at K2-18b, the distortions told a story more shocking than any we had heard before. There was water vapor in the atmosphere. There was methane. And there was oxygen. Not one, not two, but three biosignature gases lined up like a fingerprint no geology alone could forge. On Earth, that trio is the smell of life itself. The salt of the sea air, the wet soil after rain, the green breath of forests exhaling. On another world, it is either the most elaborate cosmic coincidence imaginable or a sign that something alien is breathing out there. Scientists double-checked the numbers, then triple-checked them. Still, the signals held. Methane levels were far too high to be explained by volcanism alone. Oxygen existed in amounts that should not have lasted without constant replenishment. Water vapor swirled thick in the upper atmosphere, hinting at clouds and possibly oceans beneath. Taken together, the chemistry looked familiar, almost too familiar, as if someone had taken the recipe for Earth's air and remixed it with a stranger's hand. If you could stand there, one researcher said, you might smell the sea. That single sentence stopped the room cold, because it wasn't just data anymore. It was sensation, it was human. Suddenly the alien became imaginable. What would it mean if another world shared that same breath? The implications were staggering. If those gases are biological, then K2-18b might not just host life. It might host ecosystems vast enough to shape an entire planet's atmosphere. On Earth, only forests, oceans, and billions of microbes working together can keep oxygen and methane balanced in the air. To see that balance so far away means K2-18b might be covered in oceans teeming with life, or forests stretching across, alien continents or microbial colonies carpeting the seafloor. It suggests not a flicker of biology but a chorus, not a pond but an ocean, not a breath but an atmosphere. This was not the fragile hint of life. This was a planet shouting into the void, I am alive. But the story does not end in triumph, because nature has a way of turning hope into dread. As scientists dug deeper, they began to ask, what if the signals are not signs of comfort, but of danger? Too much methane could mean vast swamps of alien biology, or it could mean chemical reactions producing toxic skies. Oxygen in high amounts sounds perfect for us, but it can also mean volatility, fire, destruction. Even water vapor is not always a gift. It can create storms so massive they shred landscapes and drown continents. The very gases that on Earth keep us alive might on K2-18b sustain life forms that would make Earth's most hostile creatures look fragile. To us, methane smells of swamps. To something else, it might smell like paradise. To us, oxygen feeds fire. To something else, it might be food. If K2-18b breathes, it may breathe in a rhythm entirely alien, one that would suffocate us instantly if we tried to join in. And there was another more haunting possibility. What if the gases didn't just come from life, but from an entire ocean of it? On Earth, the ocean is the beating heart of our biosphere. Phytoplankton alone produce half the oxygen we breathe. A single droplet of seawater holds more microorganisms than there are humans on the planet. Now imagine an ocean twice as deep, spread across an entire world, cycling methane, oxygen, and water vapor at planetary scales. If that's what Webb saw, then K2-18b is not just alive. It is drowning in life. Entire seas filled with creatures, perhaps microscopic, perhaps vast, swimming in alien rhythms, exhaling into the sky. That kind of abundance would not just be discovery, it would be revelation. But revelation can be terrifying, because an ocean that powerful, that rich, would not belong to us. It would belong to something else, something that has had millions, maybe billions of years to evolve in an environment we cannot even imagine. It may be harmless, indifferent, microbial, or it may be something far greater, something that does not see us as explorers, but as intruders. And if that ocean life were ever to grow curious, ever to look upward and wonder who else was breathing in the stars, then, for the first time in human history, we might find that the gaze we thought was one way has turned back toward us. This is the paradox of K2-18b. It is a planet that breathes, and in that breath, we hear both invitation and warning. The data feels too perfect to ignore, too clean to dismiss. It feels like proof. Yet proof can be a trap. Proof can lure us into believing we understand when in fact we are only scratching the surface. Webb showed us the gases. Webb showed us the fingerprints. But what those fingerprints belong to remains hidden in the depths of an alien sea. And perhaps the most unsettling truth is this: even if we could travel there, even if we could stand on its shores and taste its air, we might not recognize the life around us for what it is. Because on K2-18b, life may not just exist. It may exist in forms so alien that our senses, our minds, our biology are blind to them. So we are left with a world that refuses to answer, a planet that breathes but does not explain. To some it is paradise, proof that Earth is not unique. To others, it is a warning. Proof that Earth's fragility is greater than we knew. Either way, it is undeniable. K218b is alive in some sense, and in its breath lies the most haunting contradiction of all. The smell of a sea we may never touch, the whisper of life we may never meet. The reminder that paradise once found can be more terrifying than emptiness. Because in the end, K218b is not just another planet. It is a mirror, and when we look into it, the reflection is not what we expect. It breathes. And with that breath, it asks whether we are ready to breathe with it. The early universe should not have looked familiar. That was the one thing scientists were sure of. In those first billion years after the Big Bang, the cosmos was supposed to be messy, chaotic, and half-formed. Galaxies should have been clumpy little smears, their stars scattered like ink splatters on a blank page. The Milky Way itself, our majestic spiral with its graceful arms and structured beauty, took billions of years to evolve into its current shape. If you looked back far enough, the rule was simple. The farther you went, the rougher things should appear. The past should be draft form, not finished product. But then Webb peered across 11 billion years of time and found something that broke that script. It was called the Dulong Galaxy, and it looked too much like home. When Webb's golden mirrors captured the light of Dulong, astronomers expected another cosmic smear, a blurry cluster of stars clinging together by gravity's first attempts at order. Instead, they saw a perfect spiral, arms winding gracefully around a dense, luminous core, a structure not just forming, but fully formed, far earlier than any model said it should exist. To put it in human terms, it was like opening a notebook of half-written drafts, smudges and sketches, and finding, tucked between them, a complete novel polished and bound. Dulong was not a scribble. It was a finished masterpiece, written billions of years before the universe should have learned the language. This discovery struck at the heart of our understanding of galactic evolution. Spirals like the Milky Way were supposed to be late bloomers. They needed time, billions of years of collisions, mergers, star formation, and gravitational refinement. Seeing one so early was like finding a skyscraper in a village of huts. How could a galaxy skip steps in the script of time? What force fast-forwarded Dulong into elegance, while its siblings remained tangled and primitive? Astronomers scrambled for explanations, running simulations, rewriting equations, but each answer only raised more questions. If Dulong could exist that early, then perhaps the story of the universe was not a slow crawl toward order, but something far stranger, a cosmos that, in places, leaps ahead as though impatient to create structure. The implications of this discovery reached far beyond cosmic architecture. A structured spiral galaxy means stable orbits, calm star systems, and environments capable of supporting planets like Earth much earlier than expected. On Earth, life emerged billions of years after the Milky Way had stabilized. But if galaxies like Dulong existed long before, then the environments necessary for life may have existed long before as well. Imagine civilizations rising not billions of years after the Big Bang, but just one or two. Imagine life that has had a head start of billions of years on us, evolving in stable galaxies while our own was still forming. Dulong was not just a galaxy. It was a message from the past, whispering that life may not only exist elsewhere, it may have had a far longer time to thrive than we have ever dared to imagine. And here lies the paradox. The farther Webb looks, the more it sees galaxies that should not be there, structures that should not exist, order where there should have only been chaos. Each discovery is a familiar stranger, reminding us of home when it should not. The Dulong Galaxy is beautiful, yes, but its beauty is disturbing, because it suggests that our timeline is wrong. That what we thought was rare, structured galaxies, stable star systems, planets capable of nurturing life, may have been common billions of years before Earth even existed. And if that is true, then the silence of the cosmos is louder than ever. If life had a head start of billions of years, then why have we not heard it? Why do the stars not sing with voices older than our world? Why is Geelong familiar but silent? Some theorists suggest Geelong is not an outlier, but a signpost, proof that our models of cosmic evolution are incomplete. Perhaps the laws of gravity, dark matter, and star formation aligned in rare ways to create stability sooner than expected. Others whisper darker ideas. Maybe the universe itself has cycles of order and chaos, and Geelong is evidence of a previous rhythm bleeding into ours. If galaxies like this formed early, then perhaps life did too. And if life formed early, it may have risen, thrived, and fallen long before humanity ever opened its eyes. Geelong may not just be a familiar stranger. It may be the gravestone of civilizations too old to imagine, their light erased, but their structures lingering as echoes in the stars. The fear, then, is not just that the universe is stranger than we thought, but that it is older in ways we cannot grasp. That life has had more chances, earlier chances, grander chances, and yet here we are, alone. If Geelong is proof of early stability, then it is also proof of early silence. Civilizations may have risen and fallen while our own world was still molten rock. And if that is the case, then perhaps the great filter, the barrier that life struggles to cross, lies not in beginnings, but in survival. Maybe Geelong tells us that life can start easily, even thrive, but it cannot last. Maybe the silence we hear today is not emptiness, but aftermath. And yet the awe cannot be denied. To see Geelong across billions of years is to glimpse a reflection of ourselves in the deep past. A galaxy that should not look like us, but does. A structure that should not exist, but shines nonetheless. It is both comfort and terror, hope and warning. Because in Geelong's spiral arms, we see the possibility that life-supporting environments existed long before Earth. And in its silence, we see the haunting truth that even those possibilities may not save us from the fragility of existence. Geelong is a stranger, yes, but one that feels too familiar. A mirror held billions of years away, reflecting both our promise and our doom. So when we speak of Geelong, we are not just speaking of a galaxy. We are speaking of the rules of time, the architecture of life, the very foundation of our story. Geelong should not exist, but it does. And in its existence, it forces us to admit that the universe is not bound by our expectations. It writes novels where only drafts should be. It builds cities where only huts should stand. It offers mirrors where there should only be fog. And in those mirrors, we must face the most unsettling question of all. If galaxies like Geelong could host life billions of years before us, then what happened to that life? Did it thrive? Did it fall? Or is it still out there, waiting in the silence for us to notice? It is tempting to think that the great mysteries live only in the distant dark, in galaxies billions of light years away, in planets orbiting strange suns, in places so remote that light itself takes eons to reach us. But James Webb has shown us a quieter, more unsettling truth. The unknown does not always dwell at the edge of the cosmos. Sometimes it hides right next door. Even in the backyard of our own solar system, worlds we thought we understood are whispering new secrets, and few are stranger than Neptune. For nearly 2 centuries, Neptune was little more than a blue dot on star charts, a distant planet so far from the Sun that a single year there lasts 165 of ours. It was first glimpsed in 1846, discovered not by sight but by mathematics, a wobble in Uranus's orbit that betrayed its hidden neighbor. Through the 20th century, Neptune remained a mystery until Voyager 2 swept past it in 1989, capturing fleeting images of swirling storms, faint rings, and its largest moon, Triton. Voyager's visit was brief, and for decades those images were all we had. Neptune slipped back into obscurity, a frozen sentinel lurking at the edge of the solar system, until Webb looked again. When Webb turned its golden mirrors on Neptune, it revealed not a static world of ice, but a dynamic, chaotic giant, alive with unexpected phenomena. For the first time in history, we saw Neptune's faint rings in astonishing clarity, glowing like ghostly halos around the planet. These rings, once thought too dim and dusty to observe in detail, shimmered against the backdrop of deep space like scars carved into the void. And within Neptune's atmosphere, Webb revealed storms larger than Earth itself, swirling, shifting systems of methane clouds and icy winds screaming at speeds of 1,200 miles per hour. A place that looks serene from afar is, in reality, a world of violent motion. And then there was Triton, Neptune's largest moon. When Webb captured Triton in infrared, it outshone Neptune itself, glowing eerily bright, as if mocking the planet it orbits. Scientists believe Triton's surface is coated in frozen nitrogen that reflects sunlight with brutal efficiency. But beneath that icy crust may lurk a hidden ocean, warmed not by sunlight, but by tidal forces. Imagine an alien sea, buried beneath frozen darkness, pressing against the shell of a world that does not belong to Neptune at all. For Triton is not native. It is likely a captured Kuiper Belt object, a wanderer dragged into Neptune's orbit long ago. In other words, the most intriguing moon of the outer solar system may once have been its own world, stolen and imprisoned, its secrets locked away beneath a frozen mask. What Webb showed us about Neptune and Triton is not just science, is philosophy written in light. For if even Neptune, a planet we can see with backyard telescopes, hides oceans, storms and mysteries we cannot fully explain, then what does that say about the rest of the universe? If the familiar can betray us, if the ordinary can harbor the extraordinary, then perhaps our entire sense of security is fragile. The lesson is clear. Distance is not the measure of mystery. Mystery is everywhere. The alien is not just out there among galaxies like Dulong or planets like K2-18b. It is circling right here, in the blue shadow of Neptune, in the frozen silence of Triton, in the hidden oceans of our own solar backyard. And that is the emotional twist. For all our obsession with exoplanets and distant galaxies, we sometimes forget that even the worlds we thought we knew are strangers in disguise. Neptune was supposed to be familiar, just another ice giant, cold and predictable. Instead, it is chaos wrapped in blue, a reminder that the universe does not need distance to hide its secret. The frontier is not only out there, it is also here where the familiar lies waiting for us to look closer. Webb has forced us to admit that the cosmos is not split into the known and the unknown. It is all unknown, and some of it just closer to home. Individually, each of Webb's discoveries is astonishing. A galaxy forming too early, a planet that seems to breathe, a spiral that looks like the Milky Way billions of years before it should, an ice giant in our own backyard that hides oceans and chaos beneath its serene mask. Each on its own would be enough to rewrite a chapter of astronomy, to force textbooks back to the drawing board. But Webb has not delivered them one by one like isolated miracles. It has delivered them together, almost simultaneously, in a flood of revelations that seem less like chance and more like pattern. And that is what unsettles astronomers most. It is not just what Webb has found. It is what the findings mean when taken together. Consider Z14, the impossible galaxy. It should not have existed so early, yet there it was, fully formed, as if the universe skipped steps in its own construction. Then there is K2-18b, the planet that breathes, whose atmosphere carries the same trio of gases that define life on Earth. Dulong Galaxy, a spiral that should have taken billions of years to refine itself, yet sits in the deep past like a completed novel among half-written drafts. And Neptune, not a distant exoplanet, but a neighbor, still harboring storms, rings, and moons, more alien than we imagined. Put together, these discoveries form a single sentence, written across billions of years and trillions of miles. The universe does not wait. It does not crawl slowly forward in patience. It leaps, it accelerates. It cheats its own rules. This is the crack that Webb has opened in our worldview. For centuries, science has leaned on the comfort of order. Galaxies form slowly, planets evolve predictably, the solar system is stable. But Webb's discoveries mock that order. They tell us that complexity can arrive sooner than expected, that life can announce itself more loudly than we dreamed, that chaos is not out there but right here. What we once thought of as cosmic exceptions may actually be the rule. What we once thought of as our unique position may actually be common. And what we once thought of as a safe, predictable cosmos may in fact be unstable, unpredictable, even volatile. The pattern reveals itself in layers. First, the galaxies. They should have been primitive smears, yet they arrived fully formed, structured, luminous. And the planets? They should have been hostile rocks and gas, yet they breathe in rhythms that suggest biology. Then the familiar. Our own Neptune, our own Triton, showing us that even home harbors oceans we never suspected.
This is not coincidence.
It is chorus. The universe is singing, but the song is not the one we expected. It is louder, faster, and far stranger than the sheet music we've been using to follow along. And if the universe can break the rules of time and formation, then what else might it break? If galaxies can leap ahead of schedule, why not civilizations? If planets can host oceans of life earlier than expected, why not civilizations older than us by billions of years? If even our own solar system hides chaos, why not dangers hidden in plain sight? The pattern suggests a universe not built on slow inevitability, but on sudden leaps. Leaps that may give rise to life far earlier, far faster, far more abundantly than we dared to believe. And yet, in that abundance, we still hear silence. That silence is the shadow behind the pattern, the contradiction that makes it terrifying. If the cosmos is this fertile, this fast, this alive, then why aren't we surrounded by voices? This is the paradox Webb has sharpened. The discoveries suggest life-supporting environments are not rare, that structure and order arrive earlier than predicted, that even the local worlds we thought we understood are filled with surprises. The pattern suggests a universe that is not empty, but teeming, and yet the emptiness remains.
No signals, no visitors, no unmistakable evidence of civilizations, only silence.
This is the knife edge that scientists now walk. Either life is truly common, in which case the silence is deliberate or life is fragile, in which case Webb has shown us worlds that may bloom brightly only to collapse into silence themselves. In both cases, the pattern is not comfort, it is warning. What if the universe is not slow but unstable? What if physics itself trembled in the early years, producing structures and planets out of step with our expectations? What if life rises easily but falls just as easily, leaving only chemical traces in atmospheres and spiral arms in galaxies where civilizations once lived? Webb has not given us a tidy story. It has given us fragments, a galaxy too early, a planet too alive, a spiral too complete, a neighbor too strange. And in those fragments, the outline of something larger emerges, a universe that may not play by our rules, that may not care about our definitions of time, order, or life. A universe that is less a machine and more a storm, unpredictable, chaotic, and beautiful. And perhaps that is why Webb's discoveries feel so uncanny. They do not just tell us about stars and planets, they tell us about ourselves. We built models that comforted us, rules that placed us in a patient, orderly cosmos where life was a rare miracle. But Webb's pattern says otherwise. It says the miracle may be everywhere, the order may be an illusion, and the silence may be the true mystery. In the end, Webb has not just found galaxies or planets or oceans. It has found the edges of our understanding, and it has shown us that beyond those edges lies something both wonderful and terrifying. A pattern that feels like music, but may also be a warning. For centuries, physics has been the anchor of human certainty. Gravity pulls, light travels, matter forms, time moves forward. These were not beliefs, but laws. They gave us rockets, satellites, telescopes, the very instruments with which we study the stars. They gave us order in a universe that seemed incomprehensible. But James Webb has forced us to ask a question so dangerous that many scientists hesitate to even speak it aloud. What if those laws are not eternal? What if the foundations we thought unshakable can bend, shift, or even break? Z14, the impossible galaxy, already pushed us to the edge. A fully formed structure billions of years before it should exist is not just an observational curiosity. It is a direct challenge to the models of cosmic evolution. According to the equations, galaxies cannot gather that much matter so quickly without gravity, dark matter, and cooling gases following predictable rates. Yet Z14 defied those rates, standing like a skyscraper where there should only be scaffolding. Geelong too raised the same flag, a spiral too elegant, too stable, too soon. And then there was K218b, whose atmosphere suggested biosignatures that by all odds should not align so perfectly. These are not just anomalies. They are hints that the equations themselves may be incomplete. The danger of rewriting physics is that it means rewriting reality. If constants like the speed of light or the strength of gravity were even slightly different in the early universe, structures could form faster. If the laws governing matter cooled in different ways, planets could host life sooner. Some physicists have quietly suggested that Webb's discoveries might be evidence of variable constants, that what we assume to be fixed numbers in nature may have shifted in the deep past. Imagine a world where gravity pulled just a little harder, where atoms bonded a little faster, where time itself flowed differently. That world would not need billions of years to make galaxies or planets. It could leap into structure almost overnight. And yet, if the laws were different once, then the fear follows. What stops them from changing again? We like to believe that physics is not just descriptive but eternal, that the constants we measure today are the same constants that shaped the first stars and will govern the last. But what if they are not? What if we are living inside a universe that occasionally flexes its rules like a storm shifting its winds? For life on Earth, stability has been a gift. Seasons, orbits, and gravity's pull have remained steady for billions of years. But if Webb is showing us a cosmos where stability is an illusion, then our survival may be more fragile than we ever imagined. Some theorists even whisper about multiverses, right? That our universe is not one story, but a collection of drafts. If so, then perhaps Webb's anomalies are not mistakes in physics, but echoes of another set of rules bleeding into ours. Galaxies forming too soon, planets breathing too early, structures too polished. What if they are the fingerprints of a reality next door, brushing against our own? The idea is unsettling because it suggests that physics is not universal at all. It is local, it is contextual,
and it can change.
To human imagination, the idea of shifting physics is terrifying because it strips away security. If gravity is not constant, if time can stretch or contract, if matter itself can choose different pathways, then what does safe even mean? We build civilizations on the assumption that the universe is predictable. We launch satellites trusting in orbital mechanics. We design telescopes trusting that light's speed is unchanging. But Webb has cracked that comfort. By showing us galaxies and planets that should not exist, it whispers that maybe the laws we hold sacred are only temporary agreements. That the universe may be more like a dream, consistent until the moment it decides to change. And here lies the philosophical weight. If physics can bend, then reality itself is not absolute. It is contingent. It is conditional. That realization echoes beyond astronomy, beyond equations. It means that human life, human meaning, human existence are perched on shifting foundations. We may not just be fragile in biology. We may be fragile in physics itself. The laws that allow us to breathe, to think, to build, may not be permanent scaffolding. They may be passing winds in a greater storm, and storms always change direction. Scientists now find themselves in a place they both longed for and feared. Webb has given them data they cannot explain with the old equations. They can cling to the models, forcing adjustments, or they can face the possibility that the models themselves are incomplete. The first option preserves comfort but risks blindness. The second invites chaos but also truth. And so quietly, cautiously, the idea spreads. Maybe physics itself needs rewriting. Maybe the constants are not constant. Maybe the rules we trust are not eternal. Maybe the universe is not a machine at all, but something alive, shifting, evolving, breaking its own patterns whenever it pleases. For the public, this revelation arrives with awe. For the scientists, it arrives with unease. Because rewriting physics is not just about galaxies or planets. It is about rewriting reality itself. It is about admitting that the story we thought we understood may have only been a prologue. And if that is true, then Webb has not just shown us the universe. It has shown us how little we truly know. The telescope has become a mirror, not only reflecting the stars, but reflecting our ignorance back at us. And in that reflection lies both terror and wonder. Terror that reality may be unstable, and wonder that we are alive at the very moment this truth is being revealed. So when we speak of rewriting physics, it is not hyperbole. It is necessity. The impossible galaxy demands it. The familiar stranger demands it. The planet that breathes demands it. Neptune demands it.
Taken together, these are not errors.
They are a message. A message that the universe is stranger, wilder, less predictable than we dreamed. And if physics itself can be rewritten, then so too can our place in the story. The question is not whether the laws are eternal. The question is whether we are ready for what happens if they are not. For all the data James Webb has sent back, the spectra, the images, the redshifts plotted on charts, the most haunting discovery has not been written in numbers. It is written in the silence between them. Because what Webb has truly done is hold up a mirror not only to the distant stars, but to ourselves. Each impossible galaxy, each alien world, each hidden ocean is less about them and more about us. What does it mean, after all, to find a planet that breathes? What does it mean to see galaxies mature long before ours? What does it mean to learn that even the constants of physics may not be constant at all? These are not just astrophysical questions.
They are existential ones.
They force us to ask what role humanity plays in a universe that no longer seems ordered, patient, or predictable. For centuries, we lived under the story that Earth was unique. Not just a planet, but the planet, the rare jewel in a void of silence. The Copernican shift told us Earth was not the center of the cosmos, but even then, comfort remained in believing we were special. Biology seemed fragile, and the chances of reproducing Earth's recipe felt slim. But Webb has shattered that comfort. K2-18b whispers that life's chemical breath is not unique. Geelong shouts that environments for life existed billions of years before Earth was even born. Z14 suggests that structure and order arrive faster than we ever imagined. Neptune reminds us that even in our solar system, hidden oceans and chaos exist right under our noses. The story we told ourselves, that we are alone, that life is rare, that we are special, is beginning to collapse under the weight of new evidence. And yet, the silence persists. No signals, no voices, no civilizations greeting us across the void. The contradiction is unbearable. If life has had billions of years of head start, why are we still waiting for a knock at the cosmic door? The answer may be less comforting than we wish. Perhaps life is not fragile at its beginnings, but fragile in its survival. Perhaps countless civilizations have risen, looked at the stars and wondered the same questions, only to be erased by forces they could not control. Physics shifting, environments collapsing, cosmic dice rolling against them. Webb shows us the stage is set for life everywhere, but maybe the play itself rarely lasts beyond the first act. This is where the reflection turns inward. If life is common but survival rare, then what does that say about us? Humanity may not be the miracle we thought, but the exception in a darker sense, not special because we exist, but special because we have not yet collapsed. The silence in the universe may not be absence. It may be aftermath, a graveyard of voices erased by instability, by chaos, by the same universe that creates so abundantly and destroys just as fast. And if that is true, then the question is no longer whether we are alone. The question is whether we are next.
But awe and terror live together.
For even as Webb unsettles us, it also humbles us. To realize we are not the sole miracle is not to diminish humanity, but to place it in context. We are not the climax of the story, but one verse in a cosmic song that began long before Earth and may continue long after. To look into Webb's mirror is to see both our fragility and our possibility. Yes, the universe may destroy as quickly as it creates. Yes, civilizations may rise and fall like sparks in the wind. But the fact remains, we are here now, alive, conscious, able to look outward and inward at the same time. Perhaps the meaning is not in lasting forever, but in understanding while we last. The reflection goes deeper still. If physics can bend, if galaxies can sprint ahead, if life can bloom on distant shores, then our belief in permanence is the true illusion. Everything is temporary, even the laws of reality. And so humanity's reflection is not one of pride or despair, but of humility. We are fragile, yes. But we are also rare in another way. We are witnesses. Out of all the countless stars and planets, here we are, with the technology to catch the universe in the act of revealing itself. Webb's discoveries are not just about astronomy. They are about perspective. They remind us that our place is not guaranteed, that survival is not promised, but that in this moment we can see farther, deeper, clearer than any generation before us.
That is not small.
That is monumental. And yet, the question lingers like a shadow. If life is out there, if the conditions are so common, if galaxies and planets and oceans abound, then why the silence? Perhaps the reflection Webb offers is darker than we want to admit. Perhaps the mirror shows us not our uniqueness, but our fragility. Perhaps the great filter, the invisible wall that civilizations slam into, lies ahead, not behind. Webb may not have given us hope of escape, but a warning of what happens if we do not treat our fragile oasis with care. Earth may not be special in its chemistry, but it may be special in its survival, for now. So when we say Webb has changed everything, it is not just because of galaxies and exoplanets. It is because it has forced us to ask the oldest, hardest question: who are we in this vast, unpredictable universe?
Not the rulers.
Not the chosen. Perhaps not even the survivors. Just one species on one planet in one fleeting moment of stability, staring into the cosmic mirror and realizing the reflection is more fragile than we ever imagined. Humanity's reflection is both humbling and terrifying. We are not alone, but we may be temporary. And in that truth lies the real weight of Webb's discoveries. The telescope does not just show us the stars, it shows us ourselves, and the unsettling possibility that even reality itself may not hold steady forever. For months the headlines were triumphant. Webb finds impossible galaxies. Webb detects signs of life. Webb rewrites the universe. It was the narrative people wanted: discovery, hope, clarity. Humanity loves answers, but science rarely gives them so neatly. And as astronomers pored over Webb's data, as they dissected the light of galaxies and the chemical fingerprints of planets, an uncomfortable truth began to creep in. What Webb had revealed might not be what it seemed. The numbers were real. The light was real. The images were real. But their meaning may be something else entirely. Take K2-18b, the so-called planet that breathes. When Webb captured its atmosphere, the fingerprints of methane, oxygen, and water vapor seemed like a cosmic calling card of biology. 3 biosignatures aligned in a way too precise to ignore. The narrative practically wrote itself: life. But then came the doubts. Volcanoes, it turns out, can mimic biosignatures. Massive eruptions releasing methane and sulfur into an atmosphere could create chemical imbalances that look like biology, but are nothing more than geology on overdrive. Other theories suggest that photochemical reactions, starlight splitting molecules and forging new ones, could create the illusion of life's breath without a single cell existing? What if Webb had not found a living ocean but a dying furnace? What if 99.7% chance of life is really 99.7% chance of chemistry fooling us? Or consider Z14 the impossible galaxy. Its fully formed structure so soon after the Big Bang should not exist. But perhaps it doesn't. Some astronomers argue that Webb's redshift measurements, the stretching of light that tells us distance and age, might be misinterpreted in certain extreme cases. Dust clouds, gravitational lensing, or unknown distortions could make galaxies look older and larger than they are. In that reading, Z14 may not be an impossible skyscraper rising overnight, but a mirage of light bent through cosmic glass. If so, then the laws of physics are not broken. Our instruments are simply tricked. The danger here is that the universe may not be rewriting itself. It may just be showing us how easily our eyes can be fooled. Julong 2 may not be the familiar stranger it appears. Its perfect spiral arms look like the Milky Way billions of years before schedule. But spirals are fragile structures. They blur, smear, and dissolve in collisions. For Julong to look so neat, perhaps it is not ancient at all. Perhaps gravitational lensing, the magnifying effect of massive foreground clusters bending light, has created the illusion of spiral order where none exists. What if Julong is not a mirror of home, but a distorted echo, light rearranged by invisible hands? In that scenario, the fear is not that galaxies evolve too fast, but that our instruments are not yet sharp enough to tell order from chaos. The universe, then, is not disobeying its own rules. We are misreading its handwriting. Even Neptune's revelations, as close to home as they are, come with ambiguity. Its glowing rings, its chaotic storms, its captured moon Triton, all extraordinary, yes. But do they speak to hidden oceans and alien possibilities? Or are they simply natural processes magnified by Webb's unmatched eyes? We see brightness where once there was only blur, but brightness is not proof. Triton's glow may be nitrogen ice reflecting sunlight, not evidence of a living sea. Neptune's storms may be winds we do not fully model, not a sign of deeper mysteries. Perhaps Webb has not uncovered secrets at all, but simply reminded us that we had never truly looked closely before. And then there is the most haunting possibility of all. What if Webb's greatest discoveries are not biology or broken physics, but technology, the unexplained pulses of light, the repeating signals that linger in data sets, the odd alignment of gases that seem too perfect? These could be signatures of civilizations, not microbes. But civilizations do not leave such neat traces unless they want to be seen. Some whisper the idea of techno-signatures, evidence of alien industry, energy harvesting, or even attempts at communication. But if that is the case, then why the silence? Why only hints, never voices? Perhaps because what Webb sees are not living civilizations at all, but the relics of ones long gone. The signals may be echoes, monuments written in chemistry and light, fossils of technology that burned bright and then vanished. Webb may not be showing us life, but ruins.
This is the true twist. The discoveries are real, but their meanings are not fixed. Life may be geology.
Galaxies may be mirages.
Oceans may be ice.
Signals may be ruins. Every answer Webb seems to hand us comes with a shadow of doubt, a reminder that the cosmos speaks in riddles, not in declarations. And perhaps that is the most disturbing truth of all. The telescope we built to bring clarity has instead revealed layers of uncertainty. The deeper we look, the less we know. The farther we peer, the more unstable the ground beneath us feels. Webb has not given us final answers. It has given us more profound questions than ever before. And so the phrase becomes haunting. It's not what you think. That is the refrain echoing through every Webb discovery.
That galaxy, not what you think.
That planet,
not what you think.
that atmosphere, that signal, that glow,
Not what you think.
each time we believe we have grasped the meaning, the universe pulls it away. And in that game of revelation and misdirection lies the real terror. Because if reality is not what we think, then what is it? If the rules bend, if appearances deceive, If signals mislead, then perhaps the universe is not a puzzle to solve, but a trickster to endure. Perhaps we are chasing shadows in a hall of mirrors, and Webb is the light showing us just how many mirrors there are. For the audience, this is both exhilarating and terrifying. Exhilarating because it means the story is far from over.
Terrifying because it means the story may never be simple.
The cosmos Webb reveals is not a friendly place waiting to be understood. It is a labyrinth where truth wears masks, where certainty is an illusion, where every discovery is not a conclusion, but an invitation to deeper mystery. And the invitation is clear. Step closer, look deeper, but be prepared.
Because nothing you see is what you think.
By now, the story Webb has told us no longer feels like a scientific report. It feels like myth, a new creation story written in photons and shadows. Every discovery, Z14, Geelong, K2-18b, Neptune, and the strange patterns tying them all together, has pulled us further into a narrative that is as unsettling as it is awe-inspiring. Galaxies that appear too early, planets that breathe when they shouldn't, oceans hidden in familiar places, laws of physics that wobble,
and signals that may be illusions or ruins. Together they form not a map, but a mirror.
And in that mirror, humanity sees its most difficult reflection yet, that the universe is not stable, not patient, not obedient. It is alive with contradictions, with leaps, with chaos. And Webb, for all its golden mirrors and perfect precision, has not tamed that chaos. It has simply shown us how deep it runs. The final build-up begins with the question no one wants to ask. What if we are misinterpreting everything? The galaxies that seem impossible, are they truly rewriting physics, or are they showing us how fragile our equations are? The planets that seem to breathe, are they homes or are they traps? The familiar spirals, are they evidence of life's early opportunities or gravestones of civilizations that never survived? Even Neptune's glow, and is it wonder, or is it simply another mask of nature reminding us we've never looked closely enough? Webb gives us certainty in its data, but it strips us of certainty in meaning, and that is the paradox of its gift. We know more, but we understand less. We see clearer, but the picture grows stranger. This is where the weight falls on humanity's shoulders. Because, for centuries, we told ourselves a comforting story that the universe is vast but ordered, that life is rare but possible, that we are fragile but meaningful. Webb challenges all of those. If life is common, then our uniqueness collapses. If galaxies leap ahead, then our models fail. If physics itself can shift, then our security is an illusion. And if silence persists despite abundance, then survival may not be guaranteed. Webb has not just shifted astronomy. It has shifted philosophy, theology, psychology. It has forced us to face not the stars, but ourselves. Who are we in a universe that does not wait, does not obey, and does not explain? Who are we if reality itself can crack? And then comes the haunting cliffhanger. If a planet exists with a 99.7% chance of life, why are we still alone?
That number should be a triumph.
It should be a victory cry, the final nail in the coffin of loneliness. Yet instead, it deepens the silence. Because if life is out there, it is either hiding, gone, or so different that we cannot see it. Each possibility is terrifying. If it is hiding, then perhaps it knows more about us than we know about it. If it is gone, then perhaps we are staring at the ruins of civilizations that burned bright and fell silent, a future that could be ours. If it is too different, then perhaps we will never recognize it, even if it is breathing right in front of us. The silence is not emptiness. It is mystery, sharpened by Webb into something unbearable. This is why the outro must return to humility. Webb has not just changed astronomy. It has changed the way we see reality itself. It has reminded us that we are fragile, temporary, uncertain, that the universe is not a puzzle waiting to be solved, but a storm we are caught in. And yet, in that storm there is awe. There is beauty. There is wonder in the very act of looking, of questioning, of daring to face the mirror even when we do not like the reflection. The meaning is not in the answers, but in the questions. Webb has not given us certainty, but it has given us wonder. And perhaps that is more important, because certainty dies.
Wonder endures.
And so we close with the paradox that began this journey. James Webb may have just found a planet that changes everything, and it's not Earth. But the real change is not in the stars. It is in us. We are different now. We are smaller, humbler, more aware of our fragility.
And yet we are also greater.
Because we are the ones who built the mirror, who dared to look into it, who are now brave enough to ask, what if reality itself is not what we think? That courage, more than any discovery, is what defines humanity's place in the cosmos. So here is the final reflection. Webb didn't just find galaxies.
It didn't just find planets.
It didn't just find mysteries. It found a question that will haunt us for generations. And the question is not whether life exists. The question is what life, the universe, and reality itself mean when the rules no longer hold. The question is what happens to us when the cosmos whispers, "It's not what you think." And the answer, if there is one, will not be written in numbers.
It will be written in us.
In how we choose to live, to survive, to wonder, in the face of a universe that is both fragile and infinite. James Webb hasn't just changed astronomy. It has changed what it means to be human. It has shown us that even the laws of reality may tremble, that life may be both abundant and absent, that silence may be the loudest truth of all. And yet, in that trembling, it has given us awe. So like, subscribe, and most of all, stay curious.
Because the story is not over.
It has only just begun.